Okay, hello friends, welcome to my YouTube channel Mathematics Made Easy. So in today's video we have this beautiful problem that we want to solve. So we have integral from 0 to pi over 2 square root of x multiplied by the Bessel function of order negative half the x. Okay, so that's the problem we want to solve in today's video. So if you are new to this channel, please don't forget to subscribe, like, comment, and then also share with your friends. Okay, share with your friend, and let's grow this channel together. All right, guys, so let's move on. Let's dive into the solution one time. All right, so the first thing for us to be able to solve this problem is to know what this Bessel function is. The Bessel function of order negative half. Okay, so the first thing I'm going to do now is to write out the general summation formula for the Bessel function of order n. Okay, so if you have Bessel function of order n of x, so this will be equal to summation of m from 0 to infinity of minus 1 raised to the power of m, okay, of m factorial, then multiplied by gamma of m plus n plus 1, then everything multiplied by x over 2, okay, raised to the power of 2m plus n. So that is the Bessel function of order n. But in this case, we have a value for n, which is negative half. All right, so we have negative half for f. So we can write this as j of negative half x. Then this will be equal to sum of m from 0 to infinity of minus 1 raised to the power of m, then over m factorial gamma of m minus, n is now negative 1 over 2. So we have negative 1 over 2 plus 1 x over 2 raised to the power of 2m minus half. All right. Okay, so minus half plus 1, that would surely give us half. Okay, so we have the Bessel function of order negative half will give us sum of m from 0 to infinity of minus 1 raised to the power of m factorial, okay, gamma of m plus half, then multiply by x over 2 raised to the power of 2m, okay, multiply by x over 2 raised to the power of minus 1 over 2, if you apply the law of indices right here. So moving on, this is also equal to, so I can bring out x raised to the power of negative half, then over 2 raised to the power of negative half. So x raised to the power of negative half is just 1 over square root of x. And then 1 over 2 raised to the power of negative half will give us square root of 2. Your law of indices is very important. So x over 2 raised to the power of negative half is now square root of 2 over square root of 5. Okay, then everything multiplied by sum of m from 0 to infinity of minus 1 raised to the power of m, okay, then over m factorial multiplied by gamma of m plus half, okay, then multiply by, x, if we apply the law of indices here also, we have x raised to the power of 2m, then multiply by 1 over 2 raised to the power of 2m will give us what? That will give us 4 raised to the power of minus m. Okay, that's also law of indices. 1 over 2 raised to the power of 2m. 1 over 2 is 2 raised to the power of minus 1. Then if you apply the law of indices, minus 1 times 2m will give us negative 2m. So 2 raised to the power of negative 2m, that will give us 4 raised to the power of minus m. All right, so we have this result form, general formula. Guys, here's another step that we are going to make. Okay, so I'm going to remind us this recursion formula. So we know that gamma of m plus 1 over 2. Okay, so this will surely give us 2m factorial over 4 raised to the power of m factorial multiplied by square root of pi. All right, and then don't forget, if you check the denominator, if we check the denominator, we have m factorial here. Okay, so if I multiply this by m factorial, that is, if I have m factorial gamma of m plus half, so this will surely give me 2m factorial multiplied by square root of pi multiplied by m factorial over 4 raised to the power of m multiplied by m factorial. So m factorial will cancel out m factorial. So what I have now is gamma of m plus 1 over 2, okay? So which will be equal to 2m factorial square root of pi, then over 4 raised to the power of m. So let's take note of that. All right, so that is what we have now. So we can rewrite all these sum as follows. So what you have now will be square root of 2 over square root of x, okay, multiplied by sum of m from 0 to infinity of minus 1 raised to the power of m, x raised to the power of 2m, 4 raised to the power of minus m, then over m factorial gamma of m plus half. So instead of that, we can write this. So which is 2m factorial square root of pi over 4 raised to the power of m. You know, this will be equal to square root of 2 over square root of x multiplied by sum of m from 0 to infinity of minus 1 raised to the power of m, x raised to the power of 2m, 4 raised to the power of minus m, okay, multiplied by 4 raised to the power of m, then everything over 2m factorial, then square root of pi. All right, so I can also bring out this square root of pi. So if I bring it out, so I'm going to have square root of 2 over square root of x, then square root of pi will give me square root of x pi, then multiply by sum of m from 0 to infinity of minus 1 raised to the power of 2m, x raised to the power of 2m. Because 4 raised to the power of minus m multiplied by 4 raised to the power of m will give us 4 raised to the power of 0, which is 1. Then everything here over 2m factorial. All right, so we can write this as square root of 2, then everything over pi x, then multiply by sum of m from 0 to infinity of minus 1 raised to the power of m, x raised to the power of 2m, then everything over 2m factorial. All right, so we are almost done, guys. What do you notice here? This is just the general formula for the cos x. Okay, so this is cos x. You know, this is the summation representation of your cos x. So that shows that the Bessel function of negative of the order negative r will surely give us square root of 2 over pi x, then everything multiplied by cos x. That is nice. That is nice. That is nice. All right, guys. And then if you check the question, we are asked to evaluate this. So we now have what our Bessel function of order negative half is. So we can now solve the integral given to us, which is integral I equal to integral from 0 to pi over 2, then square root of x multiplied by the Bessel function of negative half of x, then the x. Okay, so where this is square root of 2 over pi x, all right, then multiplied by cos x. So we have I is equal to integral from 0 to pi over 2 square root of x, then multiplied by square root of 2 over pi x, then multiplied by cos x dx. So this will be equal to integral from 0 to pi over 2. All right. So we have square root of, I can bring out square root of 2 over pi. So I have square root of 2 over pi outside here. Then I have square root of x, then multiply by 1 over square root of x multiplied by cos x dx. Okay, we can see that square root of x will cancel out square root of x. So we have I is equal to square root of 2 over pi, then integral from 0 to pi over 2 cos x dx. And remember, if you integrate cos x, so that will surely give us sin x. So we have square root of 2 over pi, then sin x. So you apply the limit from 0 to pi over 2. So we have square root of 2 over pi, then into brackets, so we have sine pi over 2 minus sine 0. Okay, and sine pi over 2 will give us 1. So we have I is equal to square root of 2 over pi, then into bracket 1 minus 0, because sine 0 is 0. So we have square root of 2 over pi. Hence, we have a beautiful beautiful solution. If you rationalize, you can, with four hands, let's rationalize and see what we get. So if you rationalize, this will give us square root of 2 pi, then over pi. Yeah, that's what we're going to give us if you rationalize. So that is actually beautiful. That's beautiful. That's beautiful. All right. Hence, or therefore, integral from 0 to pi over 2 square root of x, then multiply by the Bessel function of or the negative half of x dx equal to square root of 2 pi then over pi. So that is the answer to the problem. All right, guys. So if you like this kind of video, please don't forget to subscribe, like, comment, and share. Thanks, guys, for watching. See you next time.